we had a product between x and the square root. So we had to state the condition that 2 minus x squared is greater than or equal to 0. This is a quadratic inequality. So we wrote this and we solved it. So this product is negative between these two. So that's why the domain is between negative the square root of 2 and the square root of 2. The function exists as the square root of 2 and negative the square root of 2 is 0, but the derivative does not, because when we determined the first derivative, we realized that this cannot be 0. But this is 0 at plus or minus the square root of 2. So that's why I wrote those bars undefined. You can write undefined if you prefer, but this is what it means. Then we study the sign. Where are my props? I need my props handy. So then we study the sign. And of course, we didn't waste our time to plug in there anything. But when you plug in negative 2x squared minus 1, when we plugged in here 0, we got positive. When we plugged in here negative 1.1, this would be positive, but there is a negative in front. And the same thing here. Then we determine the corresponding y values. And plugged in this, we got 0 in this, negative 1 and 0, and so on and so forth. And we made sure that these two rows work well together. And they do. From 0 to negative 1, yes. From negative 1 to 0 to 1, yes, of course. These are the numbers. They go correctly from negative 1, 0, 1. And then from 1 to 0, yes. So obviously this is a local minimum because of the sign of the first derivative, the sequence of signs. Negative 0 at this point, positive. And this one is the other way around, positive for the slope, 0 for the slope, negative for the slope. Okay, so now we embark on the second derivative, which is really ugly, but we decided to do that. So sometimes we can figure out what's happening here from these two, but let's go ahead and find the second derivative. So first of all, the first derivative will be negative 2, that one, not this one, of course, x squared minus 1 over the square root of 2 minus x squared. Leave the negative 2 outside. So let's find the second derivative. Negative 2 will stay. The denominator becomes, anyone will help? Yes, 2 minus x squared. I agree. So now the numerator prime is, very good, times the denominator. And then minus the numerator times the denominator prime. So when I differentiate this, what do I have to write? Yes, anyone?
1/2 times x squared minus.
Right? So remember, let me write it here, right? So the square root of a function prime is 1 over 2, the square root of the function times the function prime. So it's 1 over 2, the square root of itself, right? So that same function, times the inner function prime, which is negative 2x, and I wrote it up here so because I always run out of room, you already know that. So I'm going to circle it and continue it here. Okay, so let's see. Can anyone give us the least common denominator in the numerator? So I circle it, it's continuous here. Negative 2 stays in front. 2 minus x squared will stay. And we need the least common denominator. Can we simplify it? Let me write it one more time. So 2x, the square root of 2 minus x squared. So the negative 2 with a negative, so these will all go away. So it will be plus x squared minus 1 divided by the square root of 2 minus x squared. So let's condense it a little bit. and simplify it. So I had a negative 2, but it changes into positive 2 divided by 2. So this is positive, this is gone. So I have an x and an x squared minus 1 and the square root in the denominator. Can anyone give us the least common denominator? Push, will you give us the least common denominator, please?
2x square root of 2 minus x squared. Wait.
Anyone?
Oh yeah, it's a square root of 2 minus x squared.
2 minus x squared. So then here we have what? We multiply by?
So we divide by 2, square root of 2 minus x squared times 2x, like the top, the 2x minus.
So 2 minus x squared, good. So then we have 2x. And then, anyone?
It's just going to be times 2 minus x squared.
Very good. And then here we just distribute. So this is,
X squared minus y.
that's it. Awesome. Great job. Okay, so now let's see what we can do here. Hopefully we can simplify a little bit. So this is, when I put this over 1, I will flip, so then the denominator becomes 2 minus x squared and the square root of 2 minus x squared. So now the numerator is 4x minus 2x cubed plus x cubed minus x. Any questions so far before we continue? Anyone?
I'm good.
Okay. Let me know, stop me anytime. So negative 2, so now in correct order, negative 2x cubed, descending order. So this is negative x cubed, and 4x minus x is positive 3x. 2 minus x squared and the square root of 2 minus x squared. So of course I'm going to factor out negative x, so that would be a 2x in front, and an x squared minus 3 over 2 minus x squared, the square root of 2 minus x squared. Terrible. So let's see, when is the second derivative 0? Anyone?
Zero.
Yes, one of them is 0, correct. When x is 0, very good. It has degree 3, so we have to come up with 3 solutions.
When x is the square root of 3?
2 solutions, right? So this has to have 2 solutions, right? Good. So we found the solutions. Now I'm in trouble. Let's see if my solutions fit in my table. So the 0 is perfect. The negative the square root of 3, yay! They don't. Negative the square root of 3 is here and positive square root of 3 is here, so I don't have to redo my table for more air to breathe. Excellent. So you understand that negative the square root of 3 is here and positive the square root of 3 is here, so they don't fit in the table. Awesome.
They're out of bounds for this particular one.
Out of the domain. Awesome. I couldn't even plug them in, because if I plug the square root of 3 here, I have 2 minus 3, which is a negative number. The square root of a negative number is imaginary. Awesome. It couldn't be better. Okay, then, so now I have to find the sign. We have to find the sign. I'm going to plug in here negative 1 in the second derivative. I'm going to plug in 1 in the second derivative, but I can already figure out the sign, right? Because if this is a local minimum, what should the sign be here? And we'll check in a minute. What should the sign, by the second derivative test if you want, reversed, what should the sign be here? If the function looks like this. Exactly. Excellent. Thank you, Derek. So what should the sign be here?
Negative because it's concave down.
Exactly. So let's do that. So I plug in -1. With -1, this is positive. Of course, this must be positive. I shouldn't even plug in here. This has to be positive. It's a waste of time. So, so this is, with -1, this is negative. And this is also negative because 1 minus 3 will be negative. So, as expected, it will be positive. And the function, we say, holds water. Here, when I plug in 1, this is negative, this is positive, so of course this will be negative as expected, and it will not. See how important summarizing the information is? I was able to figure out it even before testing with a number. Okay, perfect. That's all we need. One thing that is missing from here is the symmetry. So let me explain the symmetry for the function. I'm going to write it again here. So this is x, the square root of 2 minus x squared. F of -x, this will not change because -x squared is still x squared, but this will change. So this is -x, oops, the square root of 2 minus x squared. And this is the opposite of the function. This is true for an odd function which is symmetric with respect to the origin. So I'm going to write myself a note. Odd function, don't forget. And now everything that I need is right here. I don't have to look on 3 pages of work. So here it is. And let's graph it.